So children, let's recall at a glance what all have we studied about coordinate geometry, the different formulas involved depending upon the position of the points in that xy plane. So to begin with children, first we learned to find the distance between the points when the points are lying on the axis. So let's observe the first figure children and see which points are lying on the x-axis over here. We can see point A and point B. So how did we calculate distance AB? So distance AB was given by using the formula taking the difference of the x coordinates. Why? Because the points are lying on the y-axis. So its y coordinates are 0. So we just take the difference between the x coordinates. That is the greater coordinate or the larger coordinate minus the smaller coordinate will give us distance AB. What about the points, those who are lying on the y-axis? Let's see, which are they? One point is C, the other point is D. As both the points are lying on the y-axis, definitely children, the x coordinate is 0. So how do we move on to calculate distance CD? So that is given by the formula. That is the difference between the y coordinates. That is the larger y coordinate minus the smaller y coordinate will give us distance CD. Now, next to move on with, what did we learn? We learned to calculate distance between any two points. But how? If the segment joining those 2 points are parallel to either the x-axis or to the y-axis. So let's see, do we have points over here where when we join, that segment becomes parallel to either x-axis or y-axis. So let's observe the figure. Yes, we have got 2 points when joined together become parallel to your x-axis. And how did we derive the formula? What was the formula? That formula was again given by the difference in the x coordinates will give you distance RS, where RS is a segment drawn by joining and that segment becomes parallel to x-axis. So how do we get that distance between the 2 points when joined and that segment is parallel to x-axis? By the same formula, that is difference in the x coordinates, x2 minus x1. Who is x2? Who is x1? That can be the larger coordinate and x1 will be the smaller coordinate. That will give you distance RS. Then let's move on to see if you have any 2 points where after joining that segment is parallel to the y-axis. Yes, let's see. Okay, here you are. TU. TU, when you join, that segment is parallel to the y-axis. And how did you calculate the distance between 2 points when joined and that particular segment is parallel to y-axis? By the formula y2 minus y1. So distance TU was given by the formula y2 minus y1. Then later on children, we moved on to find out and derive a formula called as distance formula. What was this distance formula? It was to find the distance between any 2 points where after joining that segment is neither parallel to your x-axis nor is it parallel to your y-axis. How was it? What was the position? It was slanting. So here we can see children, when you join PQ, PQ is a segment which is neither parallel to your x-axis nor is it parallel to your y-axis. Then how did you calculate? How did you derive? And what was that formula? It was called as distance formula. How did you get the distance formula? So distance PQ in this particular case was given by the formula square root of the sum of the squares of the difference of x coordinates and the y coordinates. That is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. What was x1, y1? What was x2, y2? They were the coordinates of the endpoints of that segment. That means in this particular case, P was with coordinates x1, y1, Q, x2, y2. And distance PQ, once again I repeat children, it was derived, or this is the formula that we use to find out the distance, that is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Next, we derive the formula section formula as well as midpoint formula. Let's see what was section formula. Given any segment in the xy plane, if that segment was divided into two parts by a particular point, say P, so you could have a point, in this particular case you could have a point R, where it divides that given segment in the ratio of m:n. So let's see, observe this figure. This is a segment like your segment PQ, where point P divides this segment in any plane it can be located or positioned in, but it is divided by point P in the ratio of m:n. Then how do you calculate the coordinates of that point which is dividing that particular segment? That was given by the formula that is called as section formula. So the coordinate of P, that is x coordinate, was calculated by using the formula mx2 plus nx1 upon m plus n, and the y coordinate of P was by using the formula my2 plus ny1 upon m plus n. By using these two formulas which we have derived children earlier, we got the coordinates of that point which divides a given segment in the ratio m:n. It can be 2:1, 3:4, whatever is the ratio. Substitute the given values and you get the coordinates of that point which is dividing that given particular segment. Let's move on children. Then we saw if point P divides that given segment into two equal halves. That means, in other words, point P is a midpoint of AB. Point R over here becomes a midpoint of PQ. That means the ratio does not remain m:n, but both the ratios are equal. Why? Because P is the midpoint. Then in that case, children, we derived the formula called as midpoint formula. And how did we calculate to get the coordinate, the numerical value of x and numerical value of y of point P? That was given by the formula x is equal to x1 plus x2 upon 2 and y is equal to y1 plus y2 upon 2. This was called as the midpoint formula. The last formula that we learned in coordinate geometry was centroid formula. What is the centroid, children? It is always in reference with a triangle. But how do you get the centroid we saw? It is what? It is the point of intersection of the medians drawn in a triangle. In a triangle, we know, children, how many medians can we draw? We can draw 3 medians and they intersect each other. They pass through the same point and that point is called as centroid. You can mark it as G. So AD is a median, BE also you can say is a median, and CF also is a median, and where these 3 medians pass through, that point of intersection is called as the centroid. How do we calculate the coordinates of the centroid G? That is x and y. We saw that we derived a formula to calculate the numerical value, that is x coordinate and y coordinate of the centroid G by the formula x is equal to x1 plus x2 plus x3 upon 2 and y is equal to y1 plus y2 plus y3 upon 2. So that was called as centroid formula. So children, in this session we have recalled of all the different formulae that were very necessary to find out the distances.